Hello again, this is Jakub from Orbify. In the previous video you have seen how easy it is to create an app using our wizard, using application templates, and that with Google Earth Engine you can access some interesting data sources, as well as that you can manipulate, for example, subtract one image from another and visualize the results. We've done most of it using our wizard, our creator, but now I think it's time to do something more sophisticated, and we'll create an application from scratch. A couple of weeks ago, I read a nice article about an approach to flood detection, a naive approach to flood detection by, again, subtracting two images captured by Sentinel-1. So flood image minus base image, whatever remains may be caused by flood. Like I said, this is a naive algorithm because there may be other things that remain that are the difference between such two images. It could be vegetation, it could be other things. So by all means, this is not production grade algorithm, but this is something that allows us to slightly better understand how Orbify works, how we can manipulate images. So let's take a look at it. And by the way, we will include the URL to the article in the show notes. We will be creating naive flood detector. Here is a name, a naive flood detector, and another naive flood detector in the case, and we will do it by using our vanilla Earth Engine template, so very basic one. Now, when I open the workflow, I will see the code that was generated for us, basic code. So the input is list of dates selected by the user when they are using the workflow, and region selected by the user when launching the app. And we are returning the image, we're returning feature collection vector data. We also may return legend. Those lines won't be necessary, won't be needed anymore for us, because what we do is, well, we are going to use Sentinel-1 data. I will use insert data source button, and we'll dive into Google Earth Engine data catalog to see whether Sentinel-1 is available anywhere. Sentinel dataset, so this looks promising, and we are not after Corinne land cover or anything like this. We would like to get Copernicus 1 data. Yes, so use encode, and here it is. So the line here points us to repository of Copernicus 1, Copernicus Sentinel-1 imagery. We will be using vector vertical to vertical polarization. So here I need to filter the data properly. Like this, so selecting from all Sentinel-1 data these that are polarized vertically. So this step is done. Now we need to select the dates, right? Because floods are events that take place in very specific moment in time. The user selects the date in the UI. What we will do is we will get the date, and then calculate some dates, brackets around these dates. So here is the date, the first date from the list of dates that the user selected, and then we are selecting some surrounding around this date, so that we are searching for satellite imagery, not necessarily precisely on that date, but plus minus 4 days. Sentinel-1 temporal resolution is 6 days. So if we're looking at 8 days range, then most likely we will find at least one image that works for us. And since we are subtracting one image from another, so we've got the order date, the date on which we are looking for the flat, and now we need also dates, base dates, right? Where we are saying, okay, the situation was normal there, and there is no extra water anywhere inland. And here is base dates, right? So -12, -20 dates. So we are going 16 days in the past, and again looking at 8 days surrounding around these dates. So the step of calculating the dates from the dates that user selected is done, is in front of us, and now we can filter out imagery based on those two dates. So these lines are responsible for filtering the imagery, right? So we've got image collection. Okay, I need to paste it here, right? Because we are selecting our image collection above. So once again, we are selecting the dates, we are calculating the dates, we are selecting our image collection, and then for our image collection, we can filter the dates between order from date and order to date. So this 8 dates surrounding for our order image. The last part of this is mosaic. It's like combining imagery. Maybe there will be like, if the area of interest is large, most likely there will be more than one image that will be used. We'll be combining the image. Maybe they will be taken on different dates, but for sure in this surrounding. Similarly, for the base image. So we are again referring to this image collection obtained here, and getting all the images that are available for this area for the dates that were defined here, and then we are building one image using mosaic function. Okay, the next step here is a little bit more complicated. So, as you can imagine, there can be some noise in the imagery. So we will be smoothing our images to make sure that we remove as much noise as possible, and also, okay, so we've got this is this expression, right? So on the one hand, we are smoothing our order image, as well as smoothing our base image, and subtracting one from another, right? So this is the trick that you have seen in the previous video. We can subtract one video from another. If this looks too complicated, then we can split it into following expressions. So order image smooth order is this, right? So it's our order image smoothened, and our base smoothened is here. So smooth base equals this, right? So here we are just smoothing imagery, and then we've got smooth order, subtract smooth base. I hope that now it's very clear what we are doing, right? So first we are smoothing two images, order and base, and then from order, we are subtracting base. Whatever remains is something new that appeared in between those two pictures. This could be, again, this could be flat, this could be extra water on the land, but it also could be vegetation. So let's remember that this is more of a test and playground than a real case that we are using Earth observation to monitor some weather events. Well, the last step here is to apply thresholding. So if the difference is insufficient, then we will not bother displaying it. We are only interested in certain specific size of the difference. And the threshold, well, the threshold will define as -3. If you are wondering where from those definitions come, why I'm applying that radius of smoothing or thresholding, then this is basically directly from the article that you can find here. So let me put our definition here, -3, and last thing is returning the results. So definitely we do want to return our thresholded value. This will be the image that will be displayed to the user. But there are two other things that I would like to show to you. First thing is definition of palette. So we can define what colors will be used to visualize the results that we obtained. White will be no difference, and blue will be, so red, green, blue, will be the extra water that we have found. So drift thresholded visualize palette equals to palette. So we are returning as palette the definition of palette that we have taken from here. Another important thing, I think that you might have been missing in the previous video, is the legend, right? So what those colors means. We as builders, application builders, understand, okay, this is no difference, and this is some extra stuff that appeared. However, users may not be aware of this. So we need to define legend. And this will be our legend, right? So water is blue. In order to get this legend displayed, we will also return this dictionary that contains our legend. And if everything went fine, then our script is ready and we can test it. So I will save the changes and let me move to Krakow area and let's try to get some computations for September 2021, previous year. I remember that early in September there was a little bit of flooding from the Vistula River. So draw an area of interest. We are going to select it maybe in this location. This is pretty low, pretty close to the river. And let's see if there is some extra water that appeared. So we are going to select some actual dates for the preview. September 1st. And then in a minute or two, we will be able to see the results in the preview. Okay, 2 minutes fast forward, and the workflow failed. Let's see what happens. So when I click on this small bug, it shows me what happened in the code. Name time delta is not defined. Yeah, let me go back to the workflow, and I think I indeed forgot to import this one. So let me add it here. Time delta, save changes, and let's give our algorithm another try, right? So here I will select a date again, and well, since it's in a different date, then it could be the second. It would work as well. Now we are calculating the workflow again, and in 2 minutes we will see the results. Okay, 2 minutes later we've got the results ready, so let's see how did it go. We are seeing the legend, and there are some blue spots. So looks like there was some weather that really appeared in an area where I think that it could be flooded. This is like a small soccer field that sometimes gets too wet when the river becomes too big, and in this area as well it's quite likely to for the water to appear. So looks like in some conditions our naive algorithm works. I'm really happy about the results. I wasn't sure how it will work out, and of course now we can open the actual app, right? Because here, once again, we've been in this app builder view preview. We are tuning things, checking how they are working. And now we are going to the actual app where we can select our area of interest and see how the things in Kraków are looking. We can even, let me move this. We can change it to the satellite imagery, so it may look more spectacular if we see blue circles and other shapes in this surrounding. Once again, let me select my area of interest. Let's see if we can replicate this results. So yeah, it will be like this, quite small area of interest, and it was September 2021. Yeah, okay, the second. Kraków. So this is the app user view, right? You can imagine that I'm a guy from municipal office trying to verify whether a certain area really got flooded, or maybe I work for an insurance company and I want to verify a claim against this particular date. I might be using that sort of an interface. Okay, this is the area that is suspected to be flooded. This is the date, and now we simply need to wait a couple of minutes to verify some claims or reports of area getting flooded. It will take a couple of minutes, so I will pause again and we'll get back to the video in a couple of minutes to see the actual results. In the meantime, before I pause, the link to this article on which this whole method is based, as well link to the gist with source code that I created. Both of those links will be in the show notes. Okay, 7 minutes later, our computation is ready. We processed the data for this area, and let's visualize results. Again, the legend is visible here, and now we are waiting a moment for the data to load. Let's see if we are able to detect any floodings. So once again, this area, the white area, this is an area where no changes were noticed, and then there is this area that often gets flooded when the river carries too much water. So I think our algorithm is successful, and we've got naive flood detector that we could offer to insurance companies for processing claims, or municipal office to verify whether some flooding events took part in the vicinity. So what we have seen today is that with Google Earth Engine we can build on top of Orbify a really nice working application that within 45 lines of code is calculating dates that we are going to use for our small math exercise. Then we are obtaining Sentinel-1 data. We are filtering the data from the date ranges that we defined, and we are mosaicing. We are preparing nice image. Then we are smoothing two images, subtracting one from another, removing everything according to some predefined threshold, and then returning the results. The results, when they are visualized, look reasonable, so I'm very proud of what we accomplished. If you have any questions, let me know, let us know, and I'm really looking forward to see you orbifying things on the platform. Good luck.